this type of problem, we're asked to convert a rectangular equation to a polar equation. So let's take the point S is 1, comma, negative square root 3. This is my point in rectangular form, and I want to convert it to polar. So I'm going to list the information I know. I know x is 1, y is negative square root 3, and I also know where this point is located. X is positive and y is negative, so somewhere around here. The location of this point will be important in just a minute when we try to find our angle theta. So let's start with finding r. We know the formula for r is r squared equals x squared plus y squared, just like our Pythagorean theorem. So r squared equals 1 squared plus negative square root 3 squared. 1 squared is 1, negative squared is positive, square root 3 squared is just 3. So this tells me r squared is 4. To find out what r is, we go ahead and square root it, and we get r equals 2. Perfect. There's our first part, or our point. Now, we want to find the angle, and the only way we can find the angle is to use tangent, because tangent is the trig function that involves both x and y. So my tangent to find my angle would be theta equals tangent inverse of y over x. So let's plug into our formula. We have tangent inverse y, which is square root negative 3, over x, which is 1. Simplifying that, we get negative square root 3. Tan negative square root 3. Now this is where it's important I look at the location of my point, because on our unit circle there are 2 places where tangent is equal to negative 3. Square root 3. It's equal to negative square root 3 down here in quadrant 4, and it's equal to negative square root 3 up here in quadrant 2. So plotting this point tells me my point is in quadrant 4, and the angle that matches that is the angle measured this direction, which is the angle 5 pi over 3. So the coordinate for this point in rectangular is 1, negative square root 3, and as a polar, this point would be r, which is 2, comma, our theta, which we found to be 5 pi over 3.